Welcome to Advanced Insights. I'm Mark Papermaster, CTO and EVP at AMD. I'm excited to continue this new series where we provide just what the show name suggests, advanced insights into some of the most exciting trends and topics in technology. In this episode, we explore the world of confidential computing. Protecting sensitive data while it's being processed in the cloud is of the utmost importance to IT specialists and really to all users of cloud computing. I'm joined today by Mark Russinovich. Mark has, for the last 18 years, been with Microsoft, and for the last 10 of those years has been CTO of Microsoft Azure, one of the largest cloud installations in the world. I've really had the pleasure of working with you, Mark, and I feel like it's been a bit of a journey. We got to know each other as you guys were pulling AMD into Azure, and in fact, we've had a chance to do some fun things together. I'm looking forward to chatting with you about that journey.
Yeah, well, thanks for having me on the show, Mark. It's good. I'm looking forward to a really fun conversation.
Mark, before we jump into computing and security around computing, you're actually an author, and you've written, of course, technical journals on Windows and books on Windows. But you also have three fiction books, around the area of cybersecurity. I would love it if we just sort of kick off, and if you could make a couple of comments of how did you get into that, and how that works with your life as a CTO.
Yeah, well, sure. So I've always wanted to write a cyber thriller from when I was growing up and reading Michael Crichton's books. And in the early 2000s, it started to come up and hone in on the idea of creating a security cyber thriller based on all of the kind of cyber attacks that were happening in the late 90s and early 2000s. And it looked to me like a group that was dedicated at wreaking havoc could do so by leveraging technology. And that led to me writing the first book, Zero Day, which I completed before I joined Microsoft. We got published a few years after I joined Microsoft. And the lesson in that book was the ability for bad actors to perform cyber terrorism by leveraging computer systems and bringing them down, for example, to make a statement of some kind.
Well, I tell you, it's life imitates art, which imitates life. We all see how dependent we are on our IT infrastructure. I'm sure you couldn't have written those books without, just the deep knowledge and experience you have. Have you ever run into instances that said, yeah, that really mirrors exactly one of the scenarios in my fictional book?
Well, yes, I have. In fact, there was an attack on Saudi Aramco about a decade ago that used what are now called wiper viruses, which was very similar to what I showed in Zero Day.
Well, Mark, let's shift gears a little bit and talk about something I think our listeners would be interested in now more than ever, and that's broadly security and protecting their most vital assets. And you think about a phrase you and I use a lot. It's an industry term now: confidential computing. How do people trust that what they're doing as they run computing in the cloud or across their workspaces, how do they know that it won't be compromised? I was working on confidential computing from a standpoint of game consoles. When you think about what AMD was doing with Xbox, people used to jailbreak a console and they would take game titles, and it was really cannibalizing game console market. And so we were working with the co-development of a custom chip between AMD and Microsoft, and jointly worked on how to encrypt all of the contents. And so it would be the game titles, the software itself, but also have it be encrypted while it was running. And we took that over into our first AMD EPYC server line. And I remember, right away, you were like proponent number one of this approach. And one, I want to thank you for that. But two, really get your views on the definition of confidential computing.
Yeah, so my journey with confidential computing goes back into the early 2010s. I had been in Azure for a couple of years, and I came across a technology, the first versions of confidential computing, Intel SGX and AMD TrustZone. And those were very focused, again, on client scenarios like you mentioned, DRM, for example.
Yes.
And I looked at them and thought, with all the customers, especially in those early days of cloud, with concerns about taking their sensitive data and putting it in a public cloud where other people are running the services that potentially have access to their data, saw this technology as a way to provide assurances to them that their hoster, in our case Azure and Microsoft, couldn't get access to their data. So at the same time, Microsoft Research was looking at leveraging these technologies to do things like run pieces of Windows in them. I found out about their work in it, and I actually moved the MSR team into Azure, kind of as a temporary thing so that we could bootstrap a confidential computing effort. And we co-wrote, as part of the research, running analytics inside of these enclaves, these trusted execution environments. And there's a paper that we published in 2014. And we were thinking, what's a good title for this new kind of cloud computing? And that's what we came up with confidential computing, and thought that was a great way to characterize exactly what was going on, because this technology really provides confidentiality for the data, as well as integrity, and you need integrity for confidentiality. And so that is kind of where the name got coined. And then working with you and others in the industry, and Confidential Computing Consortium was founded, and that then became an industry standard term for this.
And so, just so folks that may not be familiar with this, I mean, if I'm running confidential compute, that means that the data that I'm running is encrypted. It's encrypted while it's actually in use. It's encrypted while it's stored. And you, as a cloud provider, Mark, you wouldn't have access to the keys for that data. Maybe you can talk just a little bit about that ecosystem, how that works, that you as a cloud provider would not even have access to my programs, my software, nor my data, which I'd be running on your cloud.
Well, let's talk about that scenario first, but then talk about, I think, where confidential computing is going, which is really about transparency, not necessarily keeping somebody away from your data, because when you talk about services, that's a very difficult promise to guarantee. But in its most fundamental form, confidential computing is I take a piece of code, I put it in a trusted execution environment, which is this enclave or black box that's protected with encryption, and then that code can request from the hardware a report that says, I am this code and I'm running in this hardware inside this black box, and then take that report and give it to something, another service, a person, a key release service, for example, is most common. And the policy can be, I'm not going to give you a key that will allow you to decrypt my data and run and do computation on it unless the report shows that I can trust you. You are the code that you say you are, and you've been authenticated by this hardware that I trust to protect my data while it's in use. At that point, if you trust it, you send over an encrypted channel the key to the code, and now the code has the key. It's in this black box, and it can start to perform computation, whether AI or analytics on top of that data. And that data is protected from the outside, including the physical access to the machine, the hypervisor, the operating system, the admins on the server, completely protected. And so that is a combination of this encryption plus attestation, which are the fundamental requirements for anything that is called confidential computing.
I don't think most people realize just how complex the layers are of the security. And I remember working with you with our colleagues in Google and elsewhere in the industry to define standards. Now here it is actually out there in production, being built in a number of products through the Open Compute Project with Project Calyptra. I'd love your views on that as a starting point, and maybe, Mark, if you could build on that, what's next?
Yeah, well, so Calyptra was a fantastic project to work with you on and continue to work with you on. And as you said, it came out of looking at the core root of trust. And the core root of trust is the fundamental piece of hardware that all of the trust of a computing system is built on top of. This core root of trust will measure the next thing that launches and ensure that it adheres to some policy. And then the next thing can do the same, and you build this chain of trust as the whole system comes up. But that fundamental piece at the very bottom what we saw is an industry where we had lots of hardware vendors across this ecosystem of all the things that go into a system, defining their own, creating their own versions of this. We saw this just unnecessary complexity and actually lower security, the fact that everybody was rolling their own and potentially introducing new vulnerabilities every time. We figured and agreed with you that if the industry got together and defined one standard and maybe a reference architecture for it, that we could have everybody's intellectual horsepower focused on making this very important, very sensitive part of the system as secure as possible, and standardizing it so that software and hardware systems then could assume that it's there and interact with it in a very reliable, predictable, testable way. And so we brought others in, including Google, and then that group grew, and thus was founded this Calyptra standard as part of OCP. And that now is what we've standardized on as an industry. More and more hardware vendors of saying, instead of rolling my own, I'm going to just adopt this. And that is just doing a great thing for increasing the security of the whole industry.
You know, it opened my eyes, Mark, of how an industry can come together on a common problem and put aside the fact that everyone partners in some ways, competes in others, but if they're aligned on a goal that just is, I'll say, foundational, that we can find a way to align and really accomplish things. And so now that chain of trust has so much opportunity to be extended. I'd like your thoughts on how that can expand next. From a firmware, from a software standpoint, and then I'm gonna as a chip guy, I'm gonna add a couple comments from a silicon point of view.
Yeah, well, I think one of the things that we look at when it comes to our supply chain, which is hardware as well as the software that comes with that hardware, firmware, what we want is the ability to ensure that it adheres to security standards and that what we get from the vendor is actually what they intended to give to us, that things are strongly identified. And this has led us to look at the broader story of supply chain, not just hardware and software and firmware, but all of the supply chain, and having a way to in an immutable way, record what actually came in and its whole process through that chain, maybe even from the factory, all the way into the manufacturers and then finally the consumers like us that procure these things and start to deploy them, where we could see there's a chain of custody and a chain of provenance and security policies and reliability policies that are being adhered to the whole way through that chain, down to we know that this piece of firmware running on this server, exactly where it came from and what life cycle it went through, and potentially even tying it back, ideally, to the source code, so that if we did suspect there was a problem with it, we could reliably connect the source and the build system that produced this. And that's especially important when it comes to supply chain attacks. And so we've been thinking about this problem for a while and started to engage with you on this, because this is another great opportunity for the industry to align on the standards for how do we record this information? How do we define the policies? How do we represent those policies? And then maybe even have reference architectures. So again, people that don't want to build their own can leverage something that is battle tested.
I think we're going to see really a groundswell response to this. I think this is game changing to create an immutable record that can really expand your confidence that you don't have rogue code, you don't have rogue elements that could have been inserted in any of the software, hardware, supply chain. And Mark, it got us thinking from an AMD standpoint that we're going to be able to add on to what you just described, because we can, in the chip design process, build on that same approach of creating an immutable record that documents exactly that the chip that was built was as designed. It wasn't altered. It wasn't, and that not only through the chip design process, but as it went through the rest of the hardware build chain before it ever gets delivered to the cloud or its end use application. And so this concept of really getting the data that captures both hardware and software. What is the metadata? What is that information behind it? What can verify that it's has not been altered? And in the case of code, that it's a revision level that's supported. I just think that's going to be incredibly powerful to gain the entire community's trust that that they can compute with confidence. It's an exciting era ahead of us in confidential computing.
Yeah, and it, like you just pointed out, it ties directly into confidential computing, because one of the things that you get out of confidential computing is this measurement that we talked about, the measurement that then translates into an attestation, and the integrity of what is actually run. So in the case of software, for example, if you have a build system that is a confidential build system, it can measure everything that went into the building of a piece of an artifact, a piece of software, and record that. That gets recorded to the ledger, that information. And then, whether it's an attested build or every time you rebuild it, you can prove that it's the exact same build process with the exact same bits coming out of it. That lets you go back and tie when something you suspect has gone wrong. Maybe there's a vulnerability, maybe there's an attack or a backdoor that you suspect. You can go back and say, at this time, running on this server, touching my data was this piece of software. And I can go back then using that information from the confidential build to this is the source code and all of the tools that went into producing this. And now I can go and audit it and see, was there vulnerability really there? Could it have been exploited? Or was there a backdoor that somehow got inserted in the supply chain? And I can do that then with guaranteed ability to audit exactly what went into it. And that's just incredibly powerful. This is why we call it code transparency. And the service that we're building is code transparency service. But like you pointed out when I talked with you, it extends beyond that to firmware and hardware as well.
Yeah, it's game changing. I mean, when you think about covering all the way down to the hardware, you're going to, in essence, if you have all of that data in immutable record, you don't need a foundry that built the chip behind walls because you've created electronic certainty. And the same thing as you come up through the whole code transparency path, you're going to have that level of confidence. And Mark, I think some listeners might say, okay, Mark, you guys are, you're playing up this as this incredible capability, but what problem is it solving? And I'm going to now segment to two industry panels that you and I were on with peers in the industry, and all of us certainly we partner on things like security, but we otherwise compete in many ways as well. And yet there was complete alignment that the killer app for confidential computing is upon us. I'd love to hear your thoughts, expand on that a little bit.
Yeah, so it's kind of interesting because the hardware capabilities of confidential computing, which have been added onto and evolved with your strong leadership on the AMD side, have now gotten to the point that is perfectly aligned with the explosion of AI, generative AI, and large language models. And one of the things that is very sensitive to many customers is exactly the data that they're sharing with these models and the responses they're getting back. I talk to many customers that it's echoes of the early 2010s when they're saying, oh, I'd love to do inference in the public cloud or speech translation in the public cloud, but this data is so sensitive. I've got concerns. And if we bring now confidential computing, intersect it with AI, and we've got confidential GPUs, you're working on confidential GPUs, then that gives us the ability to do this AI processing confidentially end-to-end, where now the cloud provider we are blocked from seeing those inputs, even if we tried to see them, and the outputs of those models. Customers' data is protected completely, and it's just such a fantastic workload because it's also a very controlled and scoped workload. One of the things when I talk with you about, hey, let's get AMD onto confidential computing, it's a big task because the services are so complicated. And if you really want the protections of confidential computing, you've got to watch what's touching data where through its whole life cycle. And in the life cycle of a traditional app, it's very complicated. In the case of AI, it's very simple. The data goes into the model and some data comes out of the model. And maybe it's a little more complicated than that in some cases, but it's still very simple compared to the complexity of IT systems and microservices and cloud-native applications. And so it's just the perfect app with the perfect security requirements coming along at the right time with the hardware capabilities showing up for it.
Yeah, because that data that went into the model and the model itself are the gold. They're the currency for companies today. It's that data is their precious data of whatever process they're running, or their customer data, or their secret recipes for their business. And the models capture that. And so it's really an alignment of a security capability right when people have this, this gold mine of data and models that they need to be able to, with complete trust, be able to, generate locally and equally run in the cloud. So the whole cloud to edge compute scenario is playing out before our eyes here.
It is, and I think just to touch on the AI scenarios, because I was referring to inference, giving the model some input, getting the output back. You touched on protecting the model itself and the value of the model. And there's two types, like the companies making frontier models, which are the very high value, very expensive to train models. They want to protect their IP. Then there's the enterprise customer that wants to take one of those frontier models or foundational models and then create a fine-tuned adapter on top of it to customize it for their domain, like make it a legal one or make it an insurance model or a medical model. Also, their enterprise IP goes into that, and they want to protect that. And confidential computing would let them protect the data that went into the fine-tuning as well as the fine-tuned model update. And then one of the scenarios that confidential computing opens the door for that I've been excited about for many years and actually predates even AI being on the scene is confidential multi-party computations. And this is where you have multiple parties. They each have their data sets. They're very high IP or very sensitive data sets. They don't want to share with others, but they realize and come together, want to share that data with an analytics job or an AI job so that they can get better insights out of it. And that's something confidential computing with confidential clean rooms supports, is parties bring their data together. They share their data not with each other. They share it with the model or the training or the analytics job. And then they take the output of that and they can share that, or maybe it goes to a subset of the parties. But now everybody's confidentiality was protected, yet everybody gets more insights out of it. And I think that is a big game changer.
Mark, when do you see that kind of capability coming to bear?
Well, so there's already ISVs on the market that, you and I spoke at the Confidential Computing Summit about a month and a half ago, and there were several ISVs there that have confidential clean room offerings. And cloud providers are creating clean rooms and confidential versions of those clean rooms as well. So this is just something that's already upon us, where you can take multiple data sets and create a fine-tuned model or create a new foundation model with very sensitive data, which has not been accessible to these models up to now because of the sensitivities, and they're behind walls because of their so high value or so sensitive. Now is potentially unlocking the door for getting models to leverage that kind of data.
I love it. And by the way, you refer to that, the conference you and I were at. I felt it was just a buzz. I mean, there was, I was shocked to see the number of startups that are focusing on confidential computing and the ideas here. And what I also loved was that people get it, that that this really starts in the cloud, and this is where a lot of the heavy lifting is being done. And so, to me, that's what I think is an aspect of the future of confidential computing that I'm excited about. I'd love your thoughts on that traversal, as well as even more broadly, Mark, in your mind, what's sort of the next era for confidential computing?
So you're exactly right, and I'm really excited about this new collaboration that we've got the opportunity for, which is confidential computing client to edge. Client has lagged cloud servers in terms of confidential computing capabilities because of the cost has been absorbed with the larger costs of the cloud systems, and we're figuring out how to scale it down and make it so that it's suitable for client environments. But as you point out, now these AI scenarios, like an AI-powered client like Windows, what we'd love to have is the AI processing, which is, again, going to be, when we imagine these assistants that are intimately familiar with your life, that you can trust, that you can interact with, really to help you. Really, that is some of the most sensitive data of all, and we need to protect it with everything we can. And so confidential computing fits perfectly there. and protecting the model that is accessing that data and providing that information to you and getting those insights from you and from all the data that surrounds you that's relevant to you. And that computation might sometimes be more economical to run on a client, and so you want confidential computing on the client. In some cases, you want to augment that or offload it to the cloud, and then you need, again, the cloud to also protect that data. And so you have this confidential computing that spans from client to cloud, where it really doesn't matter where the computation. It's going to happen wherever it's best to execute based on latency and based on cost and based on scale, whether it's the client or the cloud, but it's protected end to end. And so that is, I think, the next step in this. But really where this is all going is if you take a look at, we talk about this as protection of data while it's in use. We've gone through the evolution of protection of data at rest, where we've had encryption and things like BitLocker, to protection while it's in transit, where TLS has been introduced, and now expected. Now it's not an option. If you're not protecting your data with that while it's in transit, then you've got a security vulnerability, no matter how generic you think the data is and how unsensitive it is. We're going to see the same thing happen with confidential computing. That what's going to happen over the next 5 to 10 years, we're going to move into a phase where confidential computing today is something that you work at enabling, and 10 years from now, it's going to be what? You're running without confidential computing? How are you comfortable doing that?
It's so well said. Think about it. If I was to message you right now, what messaging app would I choose? I'm gonna be on a messaging app that's end-to-end protected. It's encrypted, and I think most anyone listening in says, "Oh, of course." And I love your point. I mean, what you're saying is that's exactly how we're going to think about end-to-end computation in the future. Of course, it's going to need to be under an umbrella of confidential computing.
Yeah, and I think it'll be interesting to watch what happens to the term confidential computing, because right now it represents something special. And 10 years from now, it's just going to be a part of every system. And so will we actually refer to, will that be a commonly used term, or is it just be computing? And yeah, of course, it's going to have confidential capability in it.
Well, I look forward to that future when it's ubiquitous, where it's not even its own term, because of course it's just there, and we have complete trust in our computation, and that our data, our software, the information we care about is fully protected. Well, Mark, it's been really great chatting with you. This is a topic that's near and dear to both of our hearts. I think we're making, as an industry, great progress. I think that's what's so fun about it is it's not any one company. It's about the ecosystem coming together to make this happen.
That's the kind of relationship that we've got and trust that we've got with each other that we've built up over time collaborating like this.
Well, it's very special, and I think we get that same sense of collaboration. And that's where the whole Open Compute project and what we've done to open some of these standards has been great. And Mark, I look forward to many more collaborations with you, but more importantly, to a new future that we are between AMD and Microsoft and our compatriots in the IT industry are banding together to create a safer environment for computing.
I think this next year is going to be really exciting because of the confluence of things, the rise of the hardware, the services that are now available with confidential computing, AI, all coming together. This next year is going to be a very exciting one for confidential computing.
Awesome. Well, I look forward to continuing the journey with you.
Likewise.
Thank you very much, Mark. I truly enjoyed chatting with Mark Russinovich about confidential computing. The main takeaways from our discussion is that the security advances are creating a confidential computing ecosystem where your software and your hardware can be encrypted, and it's now expanding that security chain of trust to cover from silicon chips to firmware to software. It's creating an incredible trusted environment. And I loved our discussion around the killer app of AI, which is going to drive such a rapid uptake of these security advances. Thank you for joining us today on Advanced Insights. And I look forward to bringing you more in-depth conversations on cutting-edge technology, industry insights, and visionary perspectives from some of the brightest minds in the field. If you enjoyed today's discussion, don't forget to subscribe to AMD on YouTube and follow me on LinkedIn so that you never miss a future episode. Technology is always advancing, and I can't wait to share more insights with you next time.